So let me introduce the next speakers. Two of my former colleagues, so I'm very happy to see them. It was 3 years ago that I brought Mercari to sponsor FOSSASIA, so they are silver sponsors, I think, so I'm very grateful for them. And I'm also very happy to see that every year more and more Mercarians, people from Mercari are joining here also with talks, so I'm very happy to see you two here. I think you were last year also here, very great. So Mercari, they will speak about Mercari and what they're doing is about, personalizing search. Please go ahead.
Yeah, thank you for the introduction. And good afternoon, everyone. Thank you for joining our session. And the topic today is the journey of personalized search in Mercari. So before we jump into the topic, let me briefly introduce our company. Mercari is Japan's largest C2C online marketplace. So we support users to list items they don't want or use anymore, and users sow the money to buy new items they want. So the company's value is to circulate all forms of value to unleash the potential in all people. And our search systems are powered by many open source tools. We use dbt for data transformation, Elasticsearch for item retrieval, and TensorFlow ranking to support machine learning models. We also use weights and bias for experiment tracking, and we use Streamlit to build our evaluation UI. So these open source tools has helped us largely increase the iteration of our experiment ranking experiment. So let's jump into our today's topic, the personalized search in e-commerce. The aim is to shift the millions of listings to find a better few that match users' intent and tastes. So let's see an example. We got a user query of Nike shoes, and ideally, we have a user profile, which indicates this user has purchased the size in UK 5. His favorite color is white. He has purchased Air Jordan. His common purchase price range is around 10K JPY. He also prefers new items rather than used ones. So the retrieval system just initially returned a large amount of items, which resulting in spending many time to browsing. And the ranking system, with knowing this user's preferences, can rank items that might meet users' interests higher, so that it will save user time to find the item he probably buy. However, this process is ideal. The difficulty is how we can learn the user's preferences and how we make items ranked by users' preferences. So to reach this goal, there are several challenges we need to face. The first challenge is that currently on Mercari, the SERP ranking is still subjective. We rank items between the item attributes and the relations between queries, so they are not ranked by users' preferences yet. And the second challenge is some queries can be ambiguous, which resulting in we don't know the user's intentions. For example, the query of One Piece. In Japan, it can be mean One Piece dress, and it can also be mean the name of the anime. So we don't know which items of category we should recommend to users. And so let's just think a moment. What kind of value will you value most when you create a ranking system to provide user with a perfect search result? So in Mercari, we will value different variations. We will value the item attributes. So for example, when users search for some fashion queries like dress, the result will be many different styles to choose from. From the result, we can see items, the dress in different colors, dress in different lengths, and dress in different materials. So it's vital for us to know what colors and textiles the user prefers so that we can prioritize these items. Yeah, and also we need to know users' preferences on the categories. Some queries like Louis Vuitton, Chanel, they are composed just by the brand names, so it will return a wide variety of item categories. From the result, you can see items from fashion, from jewelry, from the cosmetics. So if this user just want to buy perfume, the other categories are probably irrelevant to this user. So understanding user preferences on category will also help us to do the personalization. And of course, the variation of price. So for some users, they already have a very specific intention. They know what to buy. For example, like this user wants to buy macaroni and cheese items. Although the search result has much less variety in the type of item, but the difference in the quantity and quality will result in different price range. So some users may prefer paying less, while others might prefer paying more for a larger set. So price is also vital in the personalized search. And the last one is the variation in user needs. So in the process of search, the user's intention is always uncertain. Users have, so for example, when users want to shop for some fashion items, they may spend more time in browsing different styles they like. But for users have a specific intention already, they might just want to quickly find a good item with a good price. So to overcome these kind of difficulties, in Mercari, we are more focused on using users' implicit feedbacks, such as likes, views, and purchases to generate user preferences. In the following session, we will cover these 4 personalized features. The first one is device type. We use this feature to understand users' behaviors on different platforms. The second one, use views and likes to understand the user needs. And the third one, last view items, we use it to understand users' preferences on different item attributes. And the last one, user category preferences, of course, it's used to understand user preferences on categories. And this is how users interacted with our items. They can do click, like, leave comments, and proceed to purchase. So these are all the signals we use to generate users' implicit feedbacks. So now I will hand over to my colleague Miao, who will give us more technical details on the how those personalized features are generated and share the insights from our experiment.
Yeah, thanks, Lirong. My name is Miao. I'm also working in Search ML team. So next, I'm going to share some detail about the experiments we have done. So first one, if we think about the user attribute, the first attribute is device type. So we assume that user from different device may have different behavior and user preference. So here we simply add the device tab as a new feature to our search ranking model to differentiate users from iOS, Android, and web. So from the experiment result, we observed that the ranking result is actually different from different device type. And we also observed that iOS user could prefer higher price and Android user could score more on the search result. So that's some interesting finding. And we also observed that the positive business metric from all the platform. Yeah. And next, we want to integrate more the user view and like behavior. So imagine you search something and you see some familiar item from the search result, that's something that you may viewed or liked before. So in that case, you may have higher chance to purchase that items. So from this assumption, we introduce 3 new features for each item to represent if the item is recently viewed or frequently viewed by the current user. and if the item is already liked by the current user or not. And from the experiment result, we found that the model actually learned to prioritize the user viewed and liked item. However, the business metric showed negative from the A/B test. That's another interesting finding from this experiment, because we increased the exposure for the familiar items for the user. However, it can also reduce the freshness of the search results. So user using search may want to explore more new item rather than see some previous seen one. So that's also inspired our following experiment, that is use the similar viewed item. So we assume that the last viewed item from the user could represent the user interest the most, and use the last viewed item to represent user interest. We can just calculate the similarity between each item with the last viewed item. So here we calculate the lexical similarity, which is just the J-card similarity of two item name to calculate the exact keyword match. And another thing we tried is to use the cosine similarity of text embedding of the item name to try to capture the semantic distance between two words. So from the experiment result in offline, since we haven't done the A/B testing online, we found that combining the lexical and semantic similarity could improve the offline NDCG the most. And also we try to add some more context information like the SERP diversity. We found that it could further improve the offline metric. So we assume that adding more context information could help the model to find out the appropriate level to apply the personalization. And finally, category could be an important information for personalization. So we assume that based on the user previous viewed category, we can better learn what's the user preference. So here we first calculate the total view count for each user, which is how many items the user is viewed in last one day. That could represent the user activity. And next, we calculate the category view count, which is the item the user viewed for each category within one day. That could represent the user absolute interest on this category. And next, we calculate the category view ratio, which is category view count over total view count. That could represent relative interest. And on our platform, we have different category level to represent the different granularity. So yeah, we applied all these features on different category level as well. So from the experiment, we found that introducing more granularity for category level could improve the offline metric the most. And also combining both view count and view ratio could improve the metrics more. That could support our assumption that the model is better learning the both relative and absolute preference from user. Yeah, so that's basically the 4 experiments we have done in the few months, and device type, category preference, similar viewed item, and viewed and liked item. So we have some contextual feature that could represent user attribute, and document feature could help the model to capture the preference on each items. Yeah. And we are still at the very beginning of personalized search. So for the future direction, first we want to implement the real-time personalization based on the user behavior real-time on each search result. And also we want to introduce more attributes like size, color, price to better represent user preference. And last, we want to build a user embedding based on our item text embedding with the user click history. Yeah, and thanks my team, Search ML and ML Ops team, to work together on this project. And thanks everyone for listening. If you have any question, you can come to our booth, Mercari. Thanks.
Thanks, the speaker. We have a few minutes of questions. Please wait until I pass you the microphone, because otherwise you don't hear.
Hello. I was wondering if you have considered or are using any kind of collaborative filtering where you try and connect what the things that I like or purchase or view to other people like me and then use that for recommendations. It seems like it's a standard thing, so I was curious.
Yeah, that's a good question. So basically, that's like similar with our direction to build a user embedding. So when we build the user embedding, we will not recognize the user ID for each individual. So, and our ranking model is basically a deep neural network, and we expect everything is learned. The like similar users' behavior can be learned using user embedding and the deep neural network. Yeah.
Further questions, comments? Yeah.
From your model, it seems the data majorly come from the user behavior. Is there the parameter from the platform or product itself that might contribute to this? For example, seasonal or popularities in products, or is there any parameter that might help?
Yes. Yeah, actually, we have more other feature not related to each user, but like CTR or the time the user is exploring. So we are more categorize those features as non-personalization feature because it's like, yeah. So yeah.
Hi, thank you. I have a question because in Debian we are also seeking how to recommend users what package to use. Do you think we could use your technique to say user has used package X, Y, and so he might like to use package Z? Can we also do something like this?
Sorry, can you elaborate more about it?
Well, the thing is we have 60,000 items, Debian packages, and users can't have a good overview what might be useful for their own purpose. So if we had some data that some users usually are using some of these packages and they tend to use certain other packages, then we can give maybe some recommendation what other users could use. Was it clear enough? Or we go back to your booth and talk about this?
Yeah, sure. That would be good.
Yeah. Let me answer this. So that's hard because what they mentioned is there is interaction. This is what we call the relevance, is like, command, even purchase. So that are signals that going from the user to the system that are used to partition or measure. And in Debian, you don't have, like, people don't vote for packages, or we could, yeah. Anyway, further questions? Yeah, let's thank the speaker again.
Thank you.